We talked previously in the video how ions form, that atoms can form positive or negative charges based on their characteristics. We said that metals tend to give away electrons in bonds, and nonmetals tend to pick up electrons in bonds. Today we're going to explore further into ionic bonding and reactions that form them. An ionic bond is formed when electrons are completely transferred from one atom to another. When atoms gain or lose electrons, they form ions. Ions come in two different types: a cation, which is a positively charged atom, and an anion, which is a negatively charged atom. In an ionic bond, we create one cation and one anion. Even though they will look like individual atoms with different charges, the attraction between the negative and positive atoms will keep them together in a bond. Atoms want 8 valence electrons in their outermost energy level to be stable. In ionic bonding, atoms can achieve the stability with the electron transfer. For example, in a compound of sodium chloride or table salt, the sodium atom originally has one extra electron hanging out in its outermost energy level. By pairing with chlorine, which has 7 in its outermost energy level, sodium can give away the extra electron, bringing its outermost ring to the one prior, creating 8 total valence electrons. Sodium is now written with a +1. Chlorine will have taken that extra electron and put it with its other 7 valence electrons to create 8. Chlorine is now written with a -1 charge. When we are writing this compound, we omit the charges because a +1 and a -1 charge cancels out. If the charges don't cancel out, we will do the crisscross method using their charges. Let's look at some examples. Our first example is sodium and oxygen. If we look at an ionic trends table, we can see that sodium has a +1 charge and oxygen has a -2 charge. When combining these elements, we would need 2 sodium atoms to overcome the -2 charge from the oxygen. When we're writing the chemical formula, we will put Na subscript 2 O. When you have atoms with different charges, if you're unsure of how many of each there needs to be, you can do the crisscross method, where you transfer the charges to being a subscript for the other atom. Also gets you the same formula and shows how many atoms there needs to be to make this compound work. Our next example is going to be magnesium and oxygen. Looking at the ionic trends table, magnesium has a +2 charge and oxygen has a -2 charge. Pause the video and try this one on your own. Like the original example of sodium and chlorine, magnesium and oxygen's charges cancel out, so we will just have one atom of each element, giving us a formula of MgO. For our last example, we are looking at aluminum and chlorine. Aluminum has a +3 charge and chlorine has a -1 charge. With the crisscross method, we will see the 3 going down to the chlorine and the 1 going to the aluminum. This creates AlCl3, or aluminum chloride. I hope you found this video helpful. If you have any questions, leave them in the comments and subscribe for more science videos.